As you know, my name is Kyneton the Genius, and today we are going to continue from where we stopped in our data science and machine learning in Python and R. We are going to continue from Model 2. We started Model 2 in the previous lesson, and today we are going to continue with Model 2. Model 2 has to do with review of relevant math topics in Python, because if you are going to become a data scientist, you need some bits of mathematics, and I'm going to give you all the maths you need to be a data scientist. About data analyst, it may be a little different. I'm not talking about data analyst. That's different from being a data scientist. Take note, I explained this before now in a different video. And also we are going to be looking at these various topics here. So these are the topics we've covered half of it. So today we are going to be starting with calculus, and then we move into statistical theory. So I'm going to quickly scroll down or move to the particular slide we are at this point. So all right, so this is where we are going to start right now. We are going to start working with differentiation in calculus. In the previous class, if you've not taken the previous lesson, that is 2.1, please do it. You've learned about two different functions, and we talked about, let me just take a different pen, np dot polyder. So basically this takes derivative of a function, and you also learned about np dot polyins. So this takes the integral, gives a definite integral of a function that is passed into this methods. So today I'm going to teach you about a different one called DiFF, D-I-F-F. This is very important because at this point you need to import another module called SymPy. Actually, this module contains several submodules that you need to import. So if you import SymPy, at this point it kind of gives you other functions that are available in NumPy, but with more. So let's do it. At this point, you'll see that SymPy tends to be easier to use. So we are going to be performing differentiation. So let's see if we can take the example on the screen. So what happens when you differentiate sine x? If you differentiate sine x, you have cos x, and if you differentiate cos x, you have minus sine x. So the first thing you want to do is to import all the submodules in SymPy. So you are going to say from SymPy import star. This is what you'll need to do. The next thing you want to do, normally if I do an import statement, I like to move the other to right and other cells. So you are now going to specify the variables that are used in this polynomial. So you are going to say x is equal to symbol x. So you are telling SymPy that x is a variable used in the equation. So if you are using the diff function, it's going to give you the derivative of this function we are going to use. So let's take, for instance, I say diff of cos x. At this point, we are not saying np.cos x because we've already imported all the submodules in SymPy. If I run it, you can see it gives us sine x, and if I say differentiate sine x, it's also going to give us cos x. Again, if we take a typical example, for instance, if we differentiate x squared plus 2x plus 1, is going to give us 2x plus 2. So if you are going to do it in Jupyter Notebook using the diff function, let's try to see. So I'm going to differentiate x squared plus 2x plus 2. So I'm going to, now I'm going to explain a little bit before I continue. Now you need to also learn how to write a mathematical function in Python format. If you're a programmer, that will be easy. So for squared, you can write it as x 2. This means it's the same thing as x squared. Of course, if it's x cubed, it's x star star 3. and so on and so forth. Again, 2x is the same as 2 times x, and so on. So you actually need to write out these equations clearly if you are using the diff function. Let's now go to do it to see how it works. So at this point, I'm going to enter the equation x squared. Let's see. Okay, so x squared plus 2x plus 2. So let's see. I'm going to differentiate x squared, this time x squared plus 2x plus 2. So let's see what we have. So you can see it gives us 2x plus 2 very easily. So the diff function is used to perform differentiation to find the derivative of a function. Again, try to take some time to read up and do the examples in the presentation right here. You can also use the diff function to take multiple derivatives or finding derivative of a derivative. And that way you have to pass in the variables more than once to be able to do that. Okay, we also have integration. I don't really know why I did not give an example. So to compute definite integral, pass the arguments integration variable, lower limit and upper limit. So okay, so I'm going to reserve this for a different time, but I think, just give me a second, let me just verify the function to be used. So so it's easier for me to do it this way because I don't need to open all my notes. Okay, so I think you use the integrate function. So let me just take an example to illustrate how to integrate. So if we want to integrate 2x plus 2, we can just say integrate 2 times x plus 2. Okay, so I'm going to run it and let's see. So it say x squared plus 2x. So try to play around with it. I don't know why I didn't put it right in my presentation. So you have diff and you have integrate. Let's now go to the key points, the key aspect that relates to machine learning and data science directly, and that is statistics with Python. The reason you need statistics is when you are talking about data science, we have to manipulate data and try to figure out what statistics this data can give us. So the models you need to know we are going to be using along the line is NumPy, SciPy, Matplotlib, Pandas, Stats model. We're going to be talking about representing our data and the interaction, data as a table, Pandas data frame, hypothesis testing, comparing two groups, linear models, multiple factors, and visualization. So we'll try to do as much as we can, and then in subsequent lessons we are going to be applying these things. I actually don't want to spend so much time learning all these mathematical functions because I believe in learning while doing at the same time. So while we are solving problems at a later model, we are going to be applying these functions and it's going to become clearer to you. So let's start with the first one. Pandas is a module that is used to manage data, to handle data frames. It's different from array. It handles data as a table. So at this point, we are going to open a file called brainsite.csv to be provided. If you look at link below, you can find a link to this file, download it, and we are going to be using it for this demonstration. A data frame is a kind of container used to store data in Pandas. It is Python's equivalent of a spreadsheet table. So a data frame is always what we are going to be using in Pandas. All right, so instead of talking all this, explaining all this theory, let's just go ahead to do it practically and you appreciate how it works. So let's start by reading data from a CSV file and viewing this data in our workspace in Jupyter Notebook. I'm going to create a new file at this point. I'm going to go back home and then create a new file. because now we are talking about statistics in Python, I'm going to just give it a name and call it statistics in Python. All right. So the first thing you want to do is to import Pandas. It's a key module that you need to always use when you are working with data. So I'm going to say import Pandas as PD. Let's give it an alias, PD. And at this point, let's now read in this data and see what this data is all about and see what data frame is all about. So I'm going to call it brain data. Brain data is equal to pd.read underscore CSV, and we specify the location of this file in our local machine. So for me, I stored it in the data brain size.csv. I think brain size.csv. I think this is the name of the file. Let me see. Brain size.csv. I think I'm getting it correct. CSV. So this is how to read in data from your local directory. Even if you have it as Excel, you only need to change, instead of read CSV, you change it to read table. So I'm going to run, and hopefully it reads this data. So how do we know that this data has come from my local system to the Python workspace? I can just say brain data. So if I just type brain data, I can view this data. But there's a problem. The data is not displayed correctly. As you can see, all the semicolon in between everywhere. So how do we handle this situation? Now it happens that Pandas allows us to specify that there is a separator in between different values inside your data set. So we are going to tell Pandas, while we are reading this data, we are going to tell Pandas that there is a separation of semicolon between the values of the values in your data set. So I'm going to just say SEP, stand for separation, is equal to semicolon. And let's read again to see how the data is going to look. So you can see that now it displays perfectly okay. And that's the beauty of Pandas in working with data. Now, sometimes you'll see missing values. As a data scientist, you need to be careful about missing values. What do you do when you have missing values in your data set? Do you replace it with 0? Do you replace it with an empty string? And so on and so forth. So in this case, missing values, the weight of the second individual is missing, as you can see. If we don't specify the missing value, then we'll not be able to perform an analysis. So we need a way to tell Pandas that this data is not available. We do that using NA. All right, so to do that, so again, I'm going to just illustrate what I'm saying. So, okay, so let's get back to Jupyter Notebook. Let's specify that this data is missing. So after specifying there is a separation, also say NA values is equal to dot. So let's say NA values is equal to dot. NA values equal to dot. Okay, so we are telling Pandas that those data are not there. So I'm going to run this point. So let's run it and let's run it. NA values is equal to dots. NA values is equal to dots. NA values, so it's not value but values. Okay, so I'm going to run again, and now you can see that it replaces it with not a number. So that is one thing you can do, kind of part of data cleaning that you need to do as a data scientist every now and then. The next thing we want to do is I'll show you how to create a range of values. For instance, you want to generate values between 0 and 100 in steps of 2 or in steps of 3. Let's try to see what we can do in this case. Now, in this example in the presentation, we have t is equal to values between -6 and +6, and we need 20 data points between these two values. Then sin t and cos t is calculated based on this range of values, and then we put it in a data frame. So let me just show you how it works. At this point, we are manually creating a data frame. Instead of importing data from our system, we are going to manually create a data frame. So the first thing we want to do is say t is equal to pd. T is equal to np dot line space from -6 to +6 to 6, and we need 20 values. All right, so I'm going to run it. I think it seems I didn't import numpy, so I'm just going to go up here and add import numpy as np. So I'm going to run this, and I'm going to go down and I'm going to run it, and it's okay. So I'm going to say sin t. Of course, you can say x is equal to that's okay. Let's use what is in the presentation. Sin t is equal to np dot sin t, okay, and cos t is equal to np dot cos t, okay. So we've created three series of data. We have t, we have sin t, in another column we have cos t, and it's made up of 20 rows, 20 observations. And now I'm going to run it. Everything is okay. In case you want to just see one of them, you can just say cos t, and it's going to display everything cos t from the values of cos t. So I'm going to take it off, just run an empty cell. So we are going to now create a pandas data frame. So again, you have the syntax. Now the syntax is very clear. The first item that is enclosed in single quotes is a header. Also, this is the single enclosed in single quotes is a header, and the next item is a series of values, the actual values of these variables that you want displayed in the data frame. So let's go ahead to do it. So take note of how I'm going to do it. I'm going to say DF. Let me store this data frame in a variable called DF. I'm going to say pd dot data frame. So take note that you are going to do something like this. We're going to start with brackets and then curly braces inside, and the first one is t colon, and then you specify t, and then comma. The next one is cos t sin t. Now let's just call it sin, and you put a colon and put the actual value, which is sin t, and then the last one comma is cos, and then colon, and then cos t. Hopefully it's gonna be fine. So I'm going to just run it and it's fine. So this data frame has been created. To view this data frame, you can just say df, and we can run it to view the data frame. So we've created a data frame in Pandas, as you can see right here. So that is about this. Try to play around and see if you can create more data frames using your own a different equation you found. And I'm going to move on to manipulating data in Pandas. Now in this case, you can view the shape of the data by saying finding the shape of the data by using the shape method. So if you say pd dot shape, not pd dot shape, actually df, because df is the name of the data frame. As you can see, we assigned it to df here. So df is the name of the data frame, and I'm going to say df dot shape is going to give us the dimension of the data, in this case 20 rows by 3 columns. Now data.columns gives you all the names of the columns, and so let's play around at this point. So now we have, let's see the columns of this data. So you can say df.columns. So it's going to give you all the columns. We have t, sin t, and cos t. if you want to select only one column of this data, you can just say DF and then specify the column you want. In this case, assuming we want just sign, you can say DF sign, DF sign. I think I need to enclose in quotes. DF sign is going to give you only that column for the particular variable you want. Now, this is a serial number that has been added. You don't have to worry about it. So I'm going to check the presentation to see if we are missing out something. So we also have selector. I'm going to explain this for you. I already understand this. And then we also have, okay, now assuming you want to filter your data, for instance, in case of our data, we want to, okay, so we have data for the gender is equal to female. So I'm going to explain it. So assuming we want to filter for values where sign t is greater than 0.5. So you can say df sign is greater than 0.5. So let's see, is greater than 0.5. Let me just make sure. Is greater than 0.5. 0.5. I don't know exactly the syntax. Okay, so df is greater than 0.5, so this is not the point. So I actually should say data df for df sign is greater than 0.5. So I can't place exactly these points, but I allow you to maybe practice it on your own. So I'm going to run it. Okay, so maybe I'm going to use data. Okay, so let's see. So let's get it right. So we have data gender where is equal to the mean. Okay, so data gender where is equal to the mean. So is greater than 0.5. Give me, okay, I think I get the point now. So let's solve it. So we have the data frame, DF, and we are selecting DF, okay, DF, where DF sign, okay. So I'm just going to check again. DF sign is greater than 0.5. The DF sign is greater than 0.5. DF, okay, I'm writing it several times. I'm going to just take out one. DF sign is greater than 0.5. Okay, so I'm going to run. Okay, so this is exactly what I want to achieve. So sometimes it's not easy, I forget how to do it. So what we're saying is that we are selecting the data frame and the criteria is inside. DF sign is going to be greater than 0.5. So you can do the same thing. It's less than 0.5. It's going to select also for values less than 0.5, as you can see. All right, so okay, so I think we're on track. Okay, so the next thing in our presentation I'm going to show you is splitting data frame. At this point, I think I should be able to get this data set so that we actually use exactly what we have in this data set. Let me see. So these very data sets, let me see. Okay, so we are going to use the brain size data set. So let's continue with the brain size data set. So we call it brain data. So at this point, let me just come here and just do exactly what we have in the presentation. So we are talking about manipulating data, and let's go ahead to do exactly what is there. So first we have data, brain data, because that is what we call it, and we have brain data, gender, where gender is equal to female, okay, and the mean of the VIQ. VIQ is also a column there, so I'm going to say the mean. Okay, so let's run it, and you see what we have is exactly the same. So splitting data using group by, so group by gender is equal to data.group by gender. So in this case, for gender, value in group by gender VIQ, I'm not going to get involved in all this. I will rather say take some time to practice it by yourself, run through the codes here, because although it's necessary, but this is not the focus of this class. Plotting data, this now is very important. Will I defer plotting data to a different time? I don't think so. Although there is another module specifically for plotting, but maybe I can just plot 1 or 2 lines for you so that you see and appreciate how plotting works. So in Pandas, you plot using plotting. So it's different from matplotlib. So I'm going to say from pandas.tools import plotting scatter matrix brain data weights. Okay, so we are plotting weights, height and MRI count, weight, height and MRI count. MRI count. So at this point we should have the outputs correctly. So something is deprecated. Okay, so we have some problem plotting this. Okay, let's see. So plotting scatter matrix, use import pandas.plotting the scatter matrix instead. Import pandas.plotting the scatter matrix. So I'm going to just say import pandas.plotting.scatter matrix. So I'm going to rerun and let's see what we have. Pandas.plotting.scatter matrix. Okay. Okay. So at least it finally worked. Anyway, we are going to be talking about plotting in more detail in a different lesson. For you, I would like to recommend you go through this yourself, try to plot it yourself and see how it works. Maybe in a different lesson, in a different tutorial, we are now going to be doing hypothesis testing in Pandas or in Python. And for you, you can try to do it yourself at this point. And in the next lesson, maybe we can do it together because we actually need to move to something a bit more important in machine learning. So what is going to be the next class? Overview of machine learning and some basic things. So I'm going to stop here and I'd like to thank you for viewing and we'll see you in the next lesson.